I'm Jeff Garland. I'm the original author of Boost Date Time. And I'm going to talk a little bit today about upgrading the library for C++ 11 and 14. An alternate title for this talk would be, features in the new library and language that you can use to build value types. Who in the room knows what I'm talking about when I talk about a value type? Okay, okay, well, I'm going to give you some references later on to go watch and see. I mean, there's a lot of good references on the web about what value types are. So this is going to be sort of an exploratory talk, so I'm going to talk about a lot of features of the language. I'm not going to talk about them in too much depth, but I'm going to give you a little bit of insight, and I'm going to show you a little bit about some of the things that I encountered in trying to use those language features. And I'm going to make at least a couple controversial statements, and I see there's a couple committee members here, so undoubtedly that'll go over well. So, how many users of Boost in the room do we have? Okay, pretty much everybody. How many users of Boost Date Time? Okay, less, half maybe. Okay. So what are we going to try and achieve here? We're going to look at some of the features, as I said, for value types. I'm going to use Boost Date Time as the primary example. If you're not familiar with Boost Date Time, there's a lot of different value types in Boost Date Time, but primarily the one I'm going to talk about today is date, and I'll highlight some of the differences from the 98 implementation. And I'll have some general conversation about what you should be looking for in a value type. So let me ask this question. How many of you have written code in C++ 11 and 14 so far? Okay. And how many of you feel like you know all the rules to be utilized to generate, say, a new class? Okay, good. Okay, even the guys at the back of the room who should know better aren't 100% sure yet. Well, that's good, I guess. I think we're all sort of in that same boat, and I know I certainly was, even after seeing a lot of presentations about maybe what it should be and how it should work. So the other little thing, you'll get a little preview of Datetime version 2. That's really the ultimate goal of what I'm working on right now, is to try and produce a version 2. So let me give you some background. These are a little bit hard to see, but version 1 of Boost Date Time was put in 129. It's ancient history, 2002. It's used in many projects now. There's some very good things about it. It's simple to use. It has a fairly powerful interface, especially for doing things like calculations associated with dates and times. It's fanatical about error checking, so it's very hard to get invalid dates and times by using the library. And it has some pretty sophisticated I/O. It didn't start out that way, but a lot of users complained bitterly that they couldn't do I/O. There's some fairly sophisticated features there if you dig into it. There are some bad things about it, like fanatical error checking. That fanatical error checking is somewhat slow. And if you don't need that fanatical error checking, then it's probably not a good thing. I would say that it's relatively hard to extend, even though there were a lot of extensibility features put in the library. They weren't really actually exploited and discussed very much in the documentation. So I'd say there are very few people who actually extend the library. They mostly just use it. Many of the bad parts are in the implementation. 295, GCC 295, anybody use that compiler? That compiler was not a good compiler, not even for C++ 98. Visual C++ 6, anyone use that compiler? Yeah. Another compiler that couldn't compile a lot of very common things that we can compile today easily. So there's a lot of bad implementation details if you dig into it. And there's some ugly things. There's a facet-based I/O system that uses strf string representations. And if you look at that, it's brutally slow. Now, part of that is just because C++ I/O is slow, okay? But it's also just part of what you're forced into when you have this kind of thing. And I can tell you that the #1 complaint about the library is it's not fast enough in the I/O for my application. And my response has consistently been, well, write your own then. But that response is kind of, one that comes with guilt. Like, gee, I should have provided more of a toolkit for people to do I/O so it's not so darn hard. So I'm not going to talk a lot about the I/O in this particular presentation, but a lot of the design decisions that are going into the version 2 relate to this particular issue. And it also relates to another goal and target, which is on the next slide. But first, I got to show you some code. So here's Boost Datetime version 1. Use the namespace Gregorian, construct a date, pretty obvious, right? I can take that date, I can add a week to it, right? I can add, some days to it as well. Simple stuff, right? Easy to read code. I can get the current time and I can compare it. I can do all the normal comparison operators. So this is, when we're talking about value types, the kind of thing you would expect to see normally in a value type. I can do comparisons, I can do copy, I can do assignment, I can do the normal things that I expect to do with a type. Okay, so who is a user of the chrono library? Okay, good. So Boost Datetime, in part, was the basis of some of the elements in the chrono library. So you'll recognize some of the same concepts. So why did we not get, the date class and the rest of the time stuff in C++11? There's a lot of reasons. There was a TR2 proposal that was made, but it was kind of too late, really. TR2 got shifted by the committee when they got busy. I will tell you right now that Datetime version 1 is a rather large library in overall, and it's my opinion that it would be very hard to standardize in that fashion, even with the TR2 proposals I made, which tried to cut things down. The committee was busy, and we got chrono, so be happy that you got that, because trust me, you're going to get worse. So these are all excuses and, major guilt and whatever, but, I have a life and a job and other things to do too. Okay, so what happened in C++11, we got a boatload of new features, right? I mean, all kinds of new language features like final, noexcept, move construction assignment, Constexpr, member initialization, enum types, user-defined literals, template aliases. There's a little function, I don't know if you've discovered this, called ToString. That's an interesting one in the library. Delegating constructors. So I'm going to cover everything in white, actually. That's why we're going to be kind of going fast and not too deep. And there's also some general class design considerations that I'm going to talk about as we go through this. I'm going to talk a lot about the construction because, obviously for a value type and any kind of class, you want to think a lot about the construction. So basically, when you consider this long laundry list of features that wasn't available in 1998 to actually work with, you really have to start over. And the meta comment that I'll make again at the end is that it's a new language. It really is. It's nothing like what we had before in terms of what you can express. And so there's many, many valuable small things here that add up to be big things at the end. Okay, so time to reconsider everything. So what's the easiest type to use in C++? Int. Exactly right. Why is int so easy to use?
When you answer that too, it's the value type.
Because it's a value type. Yeah, that's one reason. But it's a special value type. Howard?
3 letters.
3 letters. It's fast to type. Okay, well, here's a few. So one of the goals here would be to make date as easy as int. I don't think you can quite get there, but from a meta point of view, if your value type is as easy to use as int, then you've achieved something. So Boost Datetime is close, but not quite. Okay, it's really closer to double Anybody afraid of double? Yeah. Well, everybody that didn't raise their hand should be afraid of double. And if you don't know why, go type it into your Google and find out, what's wrong with double. So date can never be quite as good. So why is it so easy to use? It's hard to break, right? It never throws exceptions. So it's implicitly noexcept, basically. So you're never going to worry about exceptions in a function just because of an integer being there. It's used everywhere. You've seen it. It's fast. Everything it does is fast, right? You have a performance specification, if you will, in your brain that you're thinking about. And now in C++11, we have at least good conversions from string. So what can go wrong? Well, we could fail to initialize it. Every static checker in the universe will tell you when you fail to do that, and probably including your compiler. You could have an overflow in arithmetic. That one's not so easy. So that's problematic if you're doing a lot of that. And I don't know if you have ever seen one of those, but you can get signed, unsigned. So that's a type conversion thing that happens with int that's maybe a C legacy, I would say. So in any case, not too many downsides, right? So not too many things. So if we can channel int and we can get there, that would be good. So what are some other design considerations then as a result? So we want the date class or whatever class we have in datetime to be faster than version 1 if we can. We want to have a simpler, it's not that hard in version 1, but we want even more consistent interfaces. And I'll show you some examples of where version 1 is actually not very consistent. IO, off to work I go or something. Okay, bad jokes. Extensibility. People want to be able to extend. What do I mean by that? Well, I'll talk about it later. Want it to play nice with things like chrono, right? We have new things now, so we want to play nice. And there's a lot of legacy code with version 1. And then this last bullet was the thing I was alluding to earlier. We'd really like to find something that is tight enough, compact enough, fast enough, simple enough, universal enough that we can actually get it in the standard so that all of us can just break out the compiler and use it once and for all. Okay, so let's go through some of the C++11 and 14 features step by step and talk about how you might use them in designing the date class or some of the other classes in datetime, and I'll show you some code and some demonstrations of them. So the first one is final. Who knows what final is? Okay, so not too many actually. So final is a new keyword, and basically it supports two contexts. One context is the function context, where it prevents you from overloading a virtual function in a derived class. In the context of a class, it makes derivation an error. So let's look at date as a final class, right? Date as it's designed, even in V1, doesn't have any virtual functions. It doesn't have any virtual, doesn't have any inheritance virtual. There's no reason for anybody to derive from it, right? I mean, you could make that conclusion based on the rules you all know from Scott Myers and whoever else with C++98. So we could just write this word, class date final, like that. And if I then write this code, I actually have a whole namespace here. I'm going to get an error. And it's going to say I cannot derive from a final. Pretty nice, huh? Anybody think that's a good idea? Okay.
Excuse me.
Yes?
Is it usual practice for value types to make them final?
The question is it usual practice for?
For value types to make them.
So the question is it usual practice for value types to make them final?
What's the reason?
I don't think we have usual practice yet. So it's an interesting question. Is it? It could very well be. If I, as the author, said, yeah, I don't want to have anybody derive from this, it makes sense, Alistair.
We could always do this in C++03 anyway by having a union with a single member, and people didn't buy into that idea. It's easier now. was already mapping that.
Yes. Okay, so Alistair's saying, well, you could have done this in C++03, which is absolutely correct. There are different ways. But this is very succinct, very clear, and very obvious. And again, I'll go back to the meta comment that I think one of the big things about 20 features in C++11 is all of these sort of, Scott Meyer's practices and so forth that you might have participated in suddenly become clear and obvious to the consumer of the class. This is a clear and obvious issue. If you don't look at the class definition and you just go in your compiler and do this, you'll find out right away what's wrong. Whereas if it's, some boost class or whatever that you're looking at, it'll be a little different. There was a question here.
But I think that you should make it final as you can't derive from int either.
Okay. So the comment is that since you can't derive from int, you should make it final. I'm not sure my analogy goes quite that far. So I think in my particular case, I'm using int as an analogy for properties I want in terms of ease of use and performance primarily. So the final word on final is that ultimately none of the classes in version 2 are currently marked as final. Why? Well, one reason is, is it really invalid for somebody to extend the class with a constructor that's stateless and all it does is construct? Yeah, by certain rules and whatever, it's probably not a good idea. What if I added a stateless template member function by deriving from it? It could work just fine for your application. I'm not sure I really want to prevent that usage. It's a sneaky little trick I use, which I probably shouldn't admit to. There are no standard library types that use final, as far as I know. Now, is that a good reason not to start a trend? I don't know, but why didn't string get marked final? Why didn't some of the other types that are in the library not get marked final? Maybe they will at some point. Maybe it's just a lack of a paper, so forth. So in terms of the standardization, that's one thought.
It's very hard in existing type to be marked final because you would break existing code that had them derivation. It's an open question for new types.
Okay. So the comment from Alistair was that one good reason that the committee might not have done that on the existing types is that you could break existing usage. And that's, for new types that go in the library, maybe not a consideration. So that's a good point. Okay. More code. Same code you already saw. So what am I doing in all of these cases? Construction, construction, construction. Okay, so there's more ways to construct dates, right? I've got a string. I want to stream it in. There's a lot more ways to do that. Okay, I can say something like, give me the next weekday from this date to Sunday, and give me a new date from that. Okay, this is version 1, part of the ugly code. Okay. Nth day of the week, the first Monday in September. That's the US Labor Day holiday. Okay, so you can construct one of these function objects, and then you can call getDate on it with a year, and then you get the date. The longer I looked at that code, the more I wanted to purge it. So what's the fundamental problem?
Your API is too wide.
API is too wide. Well, that's true. But the real problem is there's too darn many ways to do this. Okay? There's too many ways in the real world to do it. So how am I going to handle that problem? So boost date time v1 is very inconsistent. I just pointed out some inconsistencies. So really, it's all about constructing the date. How do you get from month, day, year, or whatever it is into an actual date type? That's really the question. So we're going to talk now a lot about construction and some of the features. So default constructors is a basic issue for all value type classes. Move constructors is something new in C++11. Noexcept and errors is how do you handle exceptions? Member initialization is a new feature of C++11 which allows you to write your code in a different way. And templated constructors are something you can do in 98, and I'm going to talk a little bit about that. So lots of construction. All right, so what's the value of that code? Anybody know? Yeah.
2 days after your birthday.
2 days after my birthday. No. Well, the answer in Boost Datetime version 1 is it's an internal value called not a date time, and I'm going to talk a little bit about that. So, default constructor, should we even have one? I guess that's the first question, right? I mean, do we want a default constructor in class? And in 2002, when the library was initially accepted, there was no default constructor for a date, believe it or not. That made a lot of users very unhappy because they said, you know, it's just too hard. I've got all these other things, and then the thing that really sold me was std map, you know, has to have a default constructor. Yes?
I believe that's true, only square brackets operate on that.
Yeah, I was going to say, it's only for certain operations.
Yeah, but needless to say, people who are heavily using dates and maps together, yeah, they run across these little problems, yeah.
That's the ones they wanted, right?
Yeah. So it's clear that some code is clearly harder to write in a variety of ways if you can't default construct a date. So I gave in and said that's fine. So what should the value of a default constructor for a date be? Well, I could call the system clock and get the current date, which is a solution that a certain library made back in the past, which eventually led them to, in fact, create an entirely new date type because the performance was so bad when they were constructing large numbers of them, by default it was untenable. So that's one thing you could do. As I said, for version 1, it's not a date time. For version 2, the answer is it's going to be the epic. And that's because not a date time doesn't exist in version 2.
Another classic problem with default constructing the current date is two default constructed dates might not even have the same value.
That is correct. So the comment was that two default constructed dates, if you use the clock, don't have the same value. Yeah. So, but of course, once you release an API under which default construction goes to the clock and gets you the current time, you're incapable of removing that function or that behavior because you would break every program that was depending on it. And it's impossible to tell which ones were really depending on it. So this is a very fundamental question, and after a decade, I've changed my mind. So I'll talk a little bit about why I changed my mind. So I have to divert just a little bit and talk about specialness. So in version 1, there are all these things called special values, like dates and infinity and so on and so forth. It's gone in V2. I've removed it. And the reason is even though it's handy occasionally in the domain, it requires for every value type that you can imagine, like the time type, the date type, etc., at least 5 different interface methods to deal with it. Ask it if it's a special value, ask it if it's negative infinity, etc., etc. Is it not a date time? So this makes it hard to reason about your programs overall, right? I mean, it technically means that you're going to have to check. If I call a function f with a date, I'm going to have to check whether that value is not a date time, because you could pass me not a date time by default constructing it and just passing it in. And if I'm depending on the fact that it's not a date time, then I have a problem. So that's, you know, it makes it more like a double than an int, right? Because you've got all this special logic. Yes?
So I personally agree with that decision. Certainly in the case of not a date time, it does make it feel just like a double. But in the case of negative and positive infinity, I wonder if those seem like they are a little different than not a date time to me. I mean, for example, if you have an interface that takes a time out, you want to say it never times out. Say future. So,
Right. Well, you'll note that you can't say that in chrono. This is one thing that didn't carry over into chrono either, for good reason. But yeah, I guess, Howard, how would you say infinite timeout? I guess you just pick a very large number.
Yeah, if, I was thinking, you know, do you really expect your program to run 100 years? Pick 1,000.
Yeah. Yeah. I think there's, and like I say, there's valid usage in the domain. The reason I put it in there is I had written applications with my own type for a program that utilized those kind of capabilities. Yeah, because you'd say, I want this well, I can tell you the use case, right? It's I'm going to put something on the calendar, and I want this meeting to repeat forever, right? So having a way to say forever. Now, there's max date and a bunch of other things that kind of replace this, so you can still, I think, handle some of that in a different way.
If you're removing a lot of the, so you're mapping, instead of having a not a date time, you're using a real valid date in the real world. So, but now that you're doing this all in C++11, maybe you could have, did you consider just actually removing the default constructor again, even though in 98 that was needed for like string mapping and stuff. Now you can swap, there's a lot more methods on map and unordered map that you wouldn't need it. Right, so the comment is there's a lot more methods on map in C++11. Did I consider removing the default constructor? Honestly, no. It seemed to me that for those people that wanted to write code in the form where you construct a date before a while loop and you assign it somewhere down in the while loop or something, for that kind of code construct, it would be a little more inconvenient. So I didn't think about it, but it's a good point. Something to think about. Yeah. Okay. Should move along here. Okay, so here's another interesting point. After considering this for quite some time, it occurred to me that not at date time is very much like optional, which didn't quite make it in. So technically we don't have optional, but there is a proposal for optional, and certainly there's boost optional. So, the fundamental design question is, should I build this optionality into the value type itself? And I think my answer now is no. If you want this optional not at date time kind of behavior with dates, well, use optional. And then you can get that behavior. So if you want to return not a date time, return an optional of a valid date, which can just be the epoch. Okay. So advantages, we don't need the wrappers. Disadvantages, of keeping it would be you got to burden all the applications, etc. I don't think most applications I've seen actually use not at date time, by the way. It's just a rough gauge, not a scientific survey. And again, it's just complexity, right? So trying to keep it as simple as possible. All right, so that's actually a valid date. It'll give you valid behavior. Okay, it's strange behavior perhaps, but it's valid. Okay, so let's move on to move constructors. Who knows what a move constructor looks like? Okay, a lot of people. Okay, so is there going to be a lot of value in a date having a move constructor? Well, not really. It's a very simple type. So the good news is also in C++11, we have the capability of defaulting these constructors and letting the compiler generate them for us, and being very explicit about these. And I've included copy and assignment here as well from 98 for your entertainment. But basically, when you look at the internal representation of this class, it's an integer. So all of these can just be compiler generated, and it'll be as fast as it can be. This may also have some other implications later on for other things. You'll also note noexcept here. I'm going to talk about that in a few minutes. Or right now. So error handling and noexcept. So sometimes you know your data is good, and sometimes you don't. I guess it might depend on how many drinks you've had. Lame attempts at humor are supposed to work with this audience. Only chance I have to keep you awake. Okay. So, but seriously, right? I mean, sometimes you don't know whether the inputs are good. Sometimes you do. Maybe you're taking the data that you're getting off of a trusted source which you know has valid dates only. Like, for example, if I read the clock with chrono, pretty much guaranteed to get valid, good stuff. So it's impossible for me to get a date that's out of range if I read the clock. Okay? If I'm taking it from user input off of a website, I have no clue whether I'm getting it right. Although maybe I've got a bunch of JavaScript on the front end which ensures that I can never get bad stuff to the back end. So if you know it's good, you don't really want to check. So there's this whole question of checking versus not checking in the constructor. As I said, version 1 was adamant about checking everything. So the solution is to divide and conquer these two things. There's a no checking variant. That no checking variant is noexcept marked for the compiler for maximum speed. Only use it with a trusted source. The checking variant will do what version 1 does and make sure everything is still in range and throw you an exception if it's not. So what does it look like? It looks something like this. Got two different variations of the constructor. Now, I wish I could tell you that there's some huge performance boost for the noexcept version of this. At this point, I can't discern a difference. And part of that is my own problem of not enough time and not enough resources to get everything implemented cleanly to the point where I can tell. But even with simple programs that didn't involve all the machinery, I was not able to see a difference. Yes, Alistair?
If your implementation of that constructor is in line, I would expect it to have no implication for performance, because what the compiler you get from noexcept can be used and optimized out anyway. Your performance boost comes from additional code that could query the noexcept and therefore take different branches further on. But I'm not sure if such code is typical. If you're going to write those kind of noexcept operators, checking if this is noexcept to do something different in code.
All right.
If implementation's out of line, you might see a small benefit.
Right, so the gist of the comment was that if it's all in line, then it probably isn't going to make that much difference. You think that's true even if it's going to throw an exception?
On a good optimizing compiler, it can see whether or not that expression has anything that can throw, and in this case, you're just copying an int. It's not going to have anything that throws, therefore it can deduce that that whole function block has no exceptions that can
okay, so
treat the code generation as if it's no exception.
maybe I need to explain a little bit. This year, month, day is actually a structure, and it's going to take a year, month, and a day, and it's going to check whether or not you're out of range in terms of the year, the month, and the day, and if it is, it would throw an exception. So there's basically 6 comparisons and the possibility of an exception. So TBD on whether this is valuable or not. I think within the realm of move and some other things, and in the realm of Constexpr, some of this maybe comes relevant. But I don't have a final answer for you at this point. Okay, so let's talk a little bit about member initialization. Anybody know what this one looks like? This is a very simple feature. I'm going to show you another type called ISO week number. This is its implementation. It's a structure, and it has a default constructor, which is noexcept, and then it has this member initialization at the bottom. So it initializes everything out of range, basically for the way this type works. So it's constructed to an invalid state. So it's nice syntax. It allows you to do it in line. I guess it's Java-like syntax if anybody's familiar with that. But interestingly enough, you're writing default here and you're getting these values actually set by that constructor. Okay. So that's a handy thing. Okay. So as I said before, one of the fundamental problems is there's just too darn many ways. There's a gazillion ways to deal with the strings. Anybody that's tried to localize a date has flipped out. you know, there's things like ISO week number, which I just showed you. There's the day and the week and so forth. I'm going to show you some code examples of these. There's all these calculated versions. Anybody for the Klingon calendar, maybe? Mayan calendar? Oh, now that the end of the Mayan calendar has happened, I guess we don't care anymore, right? But, I mean, literally, all of these things are there. All right, so how are we going to do this? We're going to do this with a templated constructor, because I really seriously don't know what you're going to come up with next week to represent a date. And this is a common problem because people have legacy code, for example, and now they want to use a new library and they've got some old code and they want to be able to adapt it. So this is a little bit of an eye chart, but let's consider standard TM. In version 1, you called this function called date from TM after you constructed your structure and you got a date. In version 2, you just construct the date from the TM. Sorry, that's a little hard to see, I know. Let's talk about tuple and chrono. This is version 2 only. Let's say I had a tuple of int set to convenient like date time values. If you don't think this one is a valid scenario because, gee, why would you do that? Maybe you're going in and out from a database, and that's exactly how you have your data. And then you want to construct a date. So in version 2, you just construct the date. Chrono, this clever thing called a system clock now. I can get the current time from the clock. I just want to construct a date from it. Great. Again, this is v2 only. So how is this all? Oh, there's more. Wait, there's more. So here's a standard thing. Year, month, day, right? 2012, 1-1. Fine, I can construct it from that. Here's another version of year, month, date. I've got an ISO string there. Here's another year, month, date. I've got a non-ISO string. I got all kinds of strings, right? I want to be able to do that. Can't do that in V1. I got those calculated dates again. So I got this thing called day of the week. First Wednesday in January of 2013. Constructed to a date. Day of the year. First day of 2014, January 1, constructed to a date. Closest day of the week, Sunday before May 17th, 2013, constructed to a date. Okay, that's my point. Oh, wait, there's more. It just goes on and on, like it'll never end, right? ISO week numbers as strings, ISO week numbers as individual strings, ISO week numbers as integers. I mean, I can't make this up, right, guys? I mean, everybody asks, well, yeah, you know, so, okay, so I can construct it as a date. So here's the consistency, right? Every single time I construct a date, I construct it the same way, no matter what the other thing is that I'm utilizing to barter it into a date. Oh, yeah, now I got the old library, I want to construct a date. Maybe I got a p time, I want to construct a date. So how's it done? It's a templated constructor. With specializations for all the different types that are being passed in. So this allows users, right, anybody who has their date, whatever it is, to add into the library by specializing the constructor. So there would be an alternative way, which is we could define, you know, a makeDate function, and users could provide their own. So this would be like, you know, make from shared or some of the other standard library things. But to me, that just feels odd for a date. It doesn't feel right to me, which I know is a really highly technical reason. But for me, a date seems like a type like an integer, and if I'm calling a make function all the time, well, why would I have any constructors then? Yeah.
If you build a make date for something, which is something like standard begin, really, you can use it in the constructor and not have to have a whole bunch of constructors. Like you have a whole bunch of make dates. Your constructor depends on that mechanism, and you still construct just with a var, single var constructor that just calls through to make date or something like that.
Yeah, so the comment is you can have a var type constructor, which I don't cover that feature, which is another feature.
But yeah, that would be a different way to do it. You could make these and then pass it through to the constructor. And in essence, actually, there are a few things in the current implementation, like all the stuff from year, month, day. So if you can get your thing into a year, month, day, then it's very easy to construct things. Yeah. How much time do I have? How much time do I have? 15 minutes? Okay, I better move on. Okay, so, here's an example of one under the hood. Again, this is a little hard to see, but basically this is the definition or the declaration of the function in the date class. So it's date with a tref, noexcept, and here's a specialization of it. It's only a few lines of code. In this particular case, this is the one that does chrono.
Do you need a time zone or something somewhere to go from a time t to a year month day?
Yeah, so the question is, don't you need a time zone to go from this chrono thing from to a year month day? And the answer is no, because I thought there's 2 calls actually with respect to the clock. No, maybe there isn't a time zone adjusted version of it, is there? No. So time t, I guess, fundamentally is expected to be UTC. So that's how you get away with it here. So in Boost Datetime version 1, the day clock code that I showed you earlier, there's 2 different calls, one which gives you the time zone adjusted version and one which doesn't. Okay, so yeah, for chrono to be able to do all that we might want it to do, we might have to enhance clocks and time zones and add some things in there. So from a standardization point of view, this is one of the hard areas, right? Time zones is very complicated because humans are involved. It's more complicated than C++, I think, almost. So it's a problem. Yeah. So I think the point, though, is that this specialization is very easy to write in a lot of cases. If you look at the code that's in the version 2 stuff right now, most of them are only a few lines of code. Any user could write them if they know how to write a template specialization. And I've been told by people, well, that's too hard for C++ programmers. But that's a feature that's been there for a long time. I think we all need to learn how to do it if we haven't. Okay. Let's talk about some more features. User-defined literals. Who has heard of this feature? Okay, a lot of people. So I can convert a literal into a type, and C++ has some predefined ones for chrono, so let's look at those. This is a little hard to see too, but this is in std literals, chrono literals. That's the namespace there. And so I've got some code here. The traditional way of writing it would be to say hours h1, that's 1 hour. Here, though, with these literals, I can say auto and ns, 1 hour plus 20 nanoseconds, or microseconds. That's microseconds. Sorry, bug in the slide, microseconds. So there's a lot of magic in that plus operator that's part of chrono. And that's what the literal is, US and H, and then you can get that out the count. Okay, so it's nice, but for user-defined literals, there's some nuances. Back in here, we have the literal defined as H and US. It's defined in this namespace, so it doesn't collide with anything, but it's got special compensation by the compiler, which is to say that a user-defined literal that's not part of the standard library has to include an underscore. So like for week, maybe I would use underscore W. I don't know. So one of the problems I have with the user-defined literal feature is I'm not sure everything has a good literal. So other interesting point, types are limited. And how easy is this to implement? So let's dig into that a little bit. Oh, so here's a snippet of about not even half of what it
takes in the GCC representation to implement this. Now, mind you, the GCC representation overloads on double as well as on unsigned long and so forth. So there's some complications, but there's a ton of metaprogramming and other fun in here. So interesting. Anybody think they can write that code first time? Okay, we got one taker over here. I'm going to see you when I need to write it. So maybe this is a little easier. What's wrong with this? Okay, so I got my operator quote underscore D, short D, Constexpr. Looks pretty much like the chrono one. And it just returns this type called days, which is the count of the number of days. Anybody know what's wrong with this? Alistair?
Wrong argument type.
Correct. Has invalid argument list. Why? Because short is not valid according to the standard. There's a constrained set of types which are allowed to go in here. In fact, no signed type is included in the list of types that are allowed here. Now, it turns out that's all okay. All right? But the fact of the matter is when you don't know this, you're likely to run aground on it. So you have to pay attention to what the standard says about this. It took me a little while to figure out what was going on with that because I blatantly assumed, hey, I can send in whatever I want, right? That's still no joy, though. So if I change it to unsigned long, which is one of the valid types that are allowed, I still have a compile error. Next. All right, I'll tell you. So you get something to this effect that, days is not an aggregate, does not have a trivial default constructor, has no Constexpr constructor that is not a copy or move constructor. Okay? So what the problem is this type is not sufficiently Constexpr stupid enough, simple enough to support the Constexpr here. Okay? So we haven't talked about Constexpr yet. That's next up. So one thing you can do is remove the Constexpr and it will work. So the real question you should be asking yourself if you're thinking about using this feature is it worth it to me to go through a bunch of code to get something that looks like this? Now, in this case, I think it detracts readability. Yeah.
There's no requirement that literal operators be Constexpr anyway. It just
Right.
It's a runtime code.
Right. So the comment is there's no requirement for the operators to be Constexpr, and that's absolutely true. It makes it faster if it can be. Once again, all of us who are pedestrian programmers that don't crack open the standard for fun, might look at some of the implementations that are there and think, hey, I should do kind of what's there. So that's where I started with it, yeah. But yeah, obviously I realized you didn't need it. So to me, this one's a little bit more question. Okay, let's keep going. So Constexpr, who's used this feature or knows what this feature is? Okay, pretty good. Generalized constant expression, you get a function that's evaluated at compile time. In C++, it's severely, or in 11, it's severely limited. Basically, you need a single return value. You can't have much in the way of logic. You can only call other Constexpr functions. That is not removed. In 14, it's a little better. You can have if and switch. And you can have some local variables and that kind of thing. So it gets easier to write these. So what's the goodness of it, as Alistair was pointing out earlier? The nice thing is all of this is evaluated at compile time. So you have what appears to be a piece of code. It's actually evaluated down to a single value. So you can think of it as a super macro replacement in a way, if you can make it happen. Okay, so here's some obvious Constexpr for date time. I have these things like min and max, which return a single value. That works in C++ 11. Just obvious Constexpr stuff. And that is used in this thing called range check. Great. Let's consider the max date function. So this is going to give you back the maximum possible date that you can get in the system. So you write something like this: date, year, max minus 1, month max, day of month max, right? But again, not so fast. It's not an aggregate with a default constructor, da-da-da-da-da, right? We've seen that error already. Okay. So at least, and actually this doesn't compile in 14 or 11, but in point of fact, I think I'll be able to get it there because I think my current functions are just, the current implementation is just not smart enough. So I think there's a good chance that max date will be able to get there at 14. Okay. How much time do I have? 10 minutes? 5 minutes. Okay. Got to move along. We're almost there. All right, next is ToString. Who's familiar with the ToString function? Okay, good. So pretty obvious stuff. Converts things into a standard string. Integer floating type. There's also the other direction. So very, very obvious uses of this. So here's a generic range check template function. It takes a type. It takes a min and a max of that type and a value of that type and some string called unit. So I showed you the code that uses it back here. Range check year, range check month, range check day, year min, year max, and the year value. Makes it a little easier to write that code. ToString is used on the min and the max and the value when it actually throws an exception so that you get a nicely formatted exception. All right. Delegating constructors. So this basically allows you to call one constructor from another constructor. It avoids all the hassle that we used to go through of writing init with a whole bunch of variation. So here's a simple example of it. So here's a different class, year, month, day. You've kind of already seen this one. It has a const char star const year, month, day string as a constructor. And it also, like date, has a templated constructor. Here's a specialization of that constructor, which takes an std string and calls c.str on this constructor. Okay? So delegates the function up to the hard constructor. So maybe unexpected, but in the sense that, yeah, this is a template specialization, right, that's calling a hardwired constructor. Okay, so that was a fast tour of a lot of features. Few final observations. It's a whole new world. I think I've said that already. So my view on this is in some purposeful order, if you can read that. The most important function that was added, in my opinion, was toString, actually. Now, yeah, you could have called the C variations of those functions and so forth, but yeah, I use that a lot. noexcept, the explicit defaults for generated constructors. This, I think, is one of those things where I think it makes the implementation so much clearer what's going on. It's really important to be able to read that header and just see what's going on. Member initialization, yeah, it's useful. Constexpr, so far useful, but yeah, maybe it could go up a couple levels on this list, we'll see. Delegated constructors. So, these are the features I've used. The rest of them, not so much. And of course, I haven't talked about sort of more obvious things like auto and a bunch of other things, which of course are used all over the place. Auto is probably singularly the most important feature in C++ 11. All right, so some conclusions. So I guess my takeaway from working on this second time around is, some deep things to think about when you're creating a value type. Really think hard and long about how your value type integrates with others, especially if you've got a problem of legacy code and that kind of thing where you need to integrate. How does it play with things in the standard library? Does it play well and nicely with them? And look at the standard and look at some of the patterns that are in the standard, and does it follow some of those recognized patterns? So those are sort of high-level things to think about when you're designing a value type class. All right, so conclusions. Nice new features overall, I'd say, compared to the 10-year-old version of C++ or the 10 years ago, the environment is just, light years ahead. And that's partially the features. It's also just partially the compilers. The compilers are so much better now. They're so much more consistent, relatively speaking, and so forth. So I think that's really good. So when I look at the code that I'm writing, the implementation quality is just so much higher. It's not distracted with if-def for visual whatever or GCC whatever and so on and so forth. So these new features are great, but don't forget about some of the old features. There's a lot of good stuff there before. So I mentioned some other resources. If you want to really dig into this value type construction topic, I encourage you all to watch Sean Parent's 2012 C++ Now presentation. It's on the web. He's the master of value types and how they should work. And if he can't convince you, no one can. Eric Niebler did a nice talk this year on C++ 11 library design where he covers what should you write in a class. How should you write your copy constructors and your move assignments and all that. So in much more detail than I covered here today. And then this week, Wednesday at 9 a.m., Michael Casey will have the canonical class. So that's another, delve into how you should write a class in C++ 11 and 14 and some of the guidelines. All right, that's it. Questions? More questions? Yes, Jen.
You might want to fix the title. Everything not true.
Ah, right. Other questions? Yes.
Do you have, and you may not, this may be too difficult to get, but do you have any data on the most used or least used features or aspects of boost state time? I mean, even rough.
Yeah, the question is, do I have any data on the most used features?
Probably have a gut feeling, right?
Yeah, it's all gut feeling, really. And I mean, one of the things that's really hard to gauge, obviously, is that there's the people who are asking about things, and when they're asking about things, they're usually asking about something in the library they don't like. And I'll give you an example. There's a bunch of stuff for local times and time zones and other things that are in the library. And there's this thing called the time zone database thing, which allows you to create a CSV file of your own and do all kinds of conversions to your heart content, right? So the core framework there, in theory, can support historical time zones, right? But never implemented it in actuality, right? Well, I don't know what it was, 7, 8 years ago, Congress in their infinite wisdom changed the rules. And then there was a panic about people who needed this capability now to have historic time zones because they had old data and so forth that it was going to be generated on one side of the boundary or the other side of the boundary. So that became a sort of instantaneous problem that was generated by the environment. What I would say to you is that I think the core calculations and stuff like that, I think that's the stuff that gets the most used, obviously. The I/O, as I said before, is another area that there's a lot of issues and complaints about because of the speed. So the most flexible version of it is the one that uses streaming, and that's just brutal in terms of how much code you have to execute to get something in and out. And the other variations of it they lack flexibility at some level. So like I said before, I think one of my goals in version 2 is to provide much more of a toolkit approach, so that somebody that says, okay, well now I got my favorite format for a date or whatever, and I want to be able to parse it. I want you to be able to reuse some pieces without having to write a parser from the ground up or have to use I/O streams. And I'm not sure what the committee is thinking, but I/O is another no-go zone for the committee, I guess I would call it. there's not a lot of I/O capabilities in the library. I mean, the capabilities that are in Boost Datetime version 1 would dwarf everything else that's in the current standard library if it was proposed. So I have a feeling that's going to be a no-fly zone. So.
You're talking about all the faceting and whatnot.
Yeah. Now, I guess ironically, right, the faceting and all of that stuff that's in version 1, it actually builds on everything that's actually in the current, C++ standard, derived predominantly from what's in C, with some twists and turns. So, I don't know, Alistair, is there any motion with respect to I/O at this point? I know you guys are working on a lot of different things.
The trouble is we need somebody who's wildly enthusiastic about the subject to come up with something radically new that we can sell as worth having in addition to what we've got.
Yeah.
I think we've got an incredibly powerful, flexible, extensible I/O facility that's just, once you've mastered the whole thing, any specific extension is very simple. But there's a cliff to learning the whole thing because you've got to grok the whole thing all at once. And that's such a barrier that people just don't want to go down there. But because that's what we've got in place, it's then very hard to put anything else up against it because we've got this big, wonderful, powerful thing and you've not replaced all of that, but you've done something different. So it's an unfortunate barrier with where we've ended up.
Yeah.
So what's the status of version 2 right now?
Right, didn't have a slide on that. The status of version 2 at this point is it's in a very preliminary state. If you're nice to me, I'll tell you where it is on GitHub. Actually, you can search for my name and you can go find it. If you're interested in the topic and you have features that you're interested in or other feedback, I'd be happy to take that. My email address is on the first part of the slides, which I assume will be uploaded. Basically, right now, it's a work in progress. I would hope in the next few months before the end of this year, we get to a point where I have something that I think is sufficient to go to the committee. Okay, that's really the goal.
To the standards committee or to Boost?
Yeah, so the question is to the standards committee or Boost, and I guess my primary goal at this point is the standards committee, although Boost is good too. And maybe the standards committee will say, well, get it re-accepted back into Boost first, before they want to entertain it. But I think we have enough knowledge and enough, time on this, and the considerations and trade-offs, I think, are clear enough that we shouldn't have to go all that way necessarily. TBD. One of the nice things, by the way, about the current design is, to some degree, I don't have too much concern about what constructors don't make it into the standard, because I can extend it with a utilities library that gives me all the extra ones that the committee doesn't want to put in. So there's a certain amount of, I can specify the minimum thing, right? And because of like the templated constructors or something, if all these sophisticated ways of constructing a date don't get in, fine. Well, you've got Boost Datetime v2, which works beautifully with the standard, to supplement anything that doesn't actually make it in. And, it's just another variation of the theme of, I can't possibly anticipate that you're going to use the Klingon calendar, so you want to have a way of converting from XYZ, or you're going to use this set of time zones or whatever it is that you're going to use when you're constructing stuff. So I can't anticipate all that, but I've given you an open way to do all that on your own. So as long as you have that, you're good to go. And then when you start calculating and doing all that other stuff, it's all just fast. So, yes?
I don't know if this would even work, but I've been, with respect to your templated constructor, I'm a little concerned about is constructible giving the right answer. And I'm wondering if the templated constructor could be deleted, but then you go ahead and implement the specializations. If that might fix it. Maybe that's an easy fix. I don't know, I'd have to experiment.
Okay.
It's a good recipe for ODR violations.
Okay, so the first comment was is I'm sorry, what was the?
There's a trait called is constructible that
Yeah.
would be nice if it always gave the right answer.
Right, so it would is constructible give the right answer, and if it doesn't, you can have ODR violations. Or you're saying if...
It'll give you conflicting answers depending upon whether or not the specialization is visible or not.
That's correct, right.
And that's where your ODR violation comes from.
Right. Yeah, I don't know. It could be a problem. I'm not that familiar with how is constructible works, but...
I can send you an email.
Okay.
With some examples.
Okay. So, I mean, as I think I said before too, I mean, I think some feedback I received on the preliminary version of the library that, there was an indication that the other path you could go down is, these kind of make functions. For me, again, that it feels sort of sideways, but that would be another option. And I think that pretty much avoids all of that problem. So you get the minimal set of constructors, or somebody suggested, and then you have functions that can feed into it. All right, any others? All right, thank you very much.